Hello, how are you?
Hi, how are you?
Okay, let me get the lab open. We'll start in a minute or so. Okay, do you have any question before we start?
I'm good for right now.
Okay, good, thanks. So for today, you can just use your IDE. We don't require to use Linux for our lab today, so if you have your IDE, you can open that. Okay, so I think more people hopefully will be able to join us. So today we're going to address Chapter 6 content. We talked about concurrent programming using Async IO. We're going to spend time to do some exercises using Async IO, and then we are going to do an RX exercise. So to start, we are going to do Lab 7. And for Part A, that's the first part of our lab. In this one, we're going to use Async IO. So basically, you are going to make your synchronous program into asynchronous by using this library. One of the things that we're going to be implementing is called awaitables. I think we talked a little bit on this when we talked about Chapter 6 in the lecture. So what that can do is we can make it wait for a certain period of time. And with that, we need to make sure that Async IO library is installed. And so you can bring that in directly into your IDE today by adding the package. So here it talks about how we can use the module and we can look at the order of execution, because we don't necessarily going top down. We're actually finishing some of the tasks later on as we're queuing other tasks. So the program in the synchronous compared to the asynchronous, for the asynchronous is going to be the non-deterministic task that we can look at the time or the runtime, how long it takes to really execute. So in this part, it talks about how you can group the tasks and put it in a container on an array of tasks, and you can use a loop to be able to really access the task. So we are going to use range. And Async IO doesn't necessarily make things non-blocking, but it is a library that doesn't require or doesn't offer the blocking functionality. So that means that we would need to implement something to control the process from just flowing through. So we need to implement some wait time or features to be able to track your task. Okay. Now here it shows you a little bit of the format on how we would use awaitable. If you're using this with, for example, like AWS, we can implement this as a coroutine. So in the parameter here, you can see that you can pass your object, right? That would be used in sequence. But in the program itself, what you can see is that we are going to write a program and we are going to use the function that is synchronous and asynchronous to be able to control our task. Okay. So in this one, what you can do is you can use Tawny or you can use VS Code. That's up to you. We are going to use random module. We are going to use time. And that is just going to allow us to put in some pause or delay. And then we are going to use the main library for concurrent programming, which is Async.io. Okay, so let me pull up my program real quick for part A. Okay, so this program is not too long. We simply want just to do some display throughout, but from here, you can see that how we can implement functions and asynchronous function to be able to see the difference between the two when we time it. Okay, so when you look at a synchronous function, it is your basic Python function. It starts with the def. So here we have a function called task. And for the parameter, we're going to pass process ID or PID. And this is going to be for non-deterministic. And what we want to do is we want to randomly generate the values. And we're going to take that, we're going to multiply it by 0.01 seconds. And we want to print out the task, the time. Then the second function that you see in the program for part A is an asynchronous function. So therefore we need to use Async.io. So you're going to see the async key in the front. So your keyword right here. And we are going to define this as a task call, and the same parameter is used. So this allows us to create the coroutine for the non-deterministic task, and it would be the same as the other with the sleep, right? So the component is going to be the same here. But the only thing that you are going to implement that's a little different in the asynchronous is you are going to implement awaitables. So we are going to use the await keyword, and we are going to pull Async.io library. So with that, we're using the library to pause. And so that means that when it executes, it doesn't necessarily going from task 1, 2, 3, 4, 5, and so on. It will be able to queue. And you're going to see the output. That's a little different there. So it's going to pick up task 2, finishing task 1, then it's going to queue task 3, and so on. Okay, so it will be out of order on that. And then the fourth function we're going to have is called synchronous. And in this, we're simply going to use a loop. And you're going to loop from 1 through 10. And we're going to show the tasks 1 through 10. So in comparison to that, we are going to have an asynchronous function. And in this, we are going to make a coroutine. And for the coroutine, we are going to still do the loop. What it's going to do is it's going to gather the information for the task where it's going to put certain tasks on wait when it executes. Okay. And so it would finish up the task when it queues the other ones, so you can see. Now we're going to print the synchronous and we're going to print the asynchronous. So we want to see the comparison. Okay. So the program would show you the difference between a synchronous program compared to asynchronous program. So you can see how concurrent programming will work in Python. So before I run this, since I'm using a new module from the package, I need to go to tools, make sure that I add in the package. So just like what you've seen in the lecture, we are going to search for Async.io and then make sure that I install this package. Okay. And it's going to add it to my site packages. So if I had set up my system path, it should be able to execute that. Now, if you run everything through the command line, right, you need to do the pip install, and I put that here. Okay, so you need to do a pip3 install if you're running it from Linux, but you can do all of this in IDE. So when I run this, you would see that for the synchronous, it's pretty predictable where it's going to go from 1 through 9. and it shows me task 1 done, and then it's going to move to task 2, task 3, task 4, and so on until it gets to task 9. So it's simply going to be sequential from the beginning to the end task. For the asynchronous, since we implement the awaitables, right, you are going to see that we are going to take the value and we multiply it by the 0.001 of a second. So it's going to queue the task. So it's going to show you that task 1 is done. And then it's going to go and it's going to finish task 5, 7, 3, 9, 6, 4, 2, and 8. And as you can see, when you're doing the coroutines for the asynchronous, with the awaitables, when you have it paused for a very minute amount of time, you see that you can have your tasks completed while the other tasks are queuing. Okay, so you can see that. And so we don't necessarily have to go in order. And this would be used for non-deterministic type of tasks. Okay. So we can shave off some time by doing this because we would implement a way that we can handle, right, multiple tasks at the same time. Okay, so instead of waiting for one task to completely done, like 2 after the 1, I can start the next few tasks and be able to queue those while we wait for one of the tasks to be complete. And that's how you can improve the performance in the program. Any question? So this shows you the task execution, and in the next few program, you're going to see the time difference when you do concurrent programming. So for the synchronous program, the simple Python traditional synchronous program, it is simply just going to go from the beginning to the end as expected. But with the asynchronous, we can definitely implement the coroutines and the awaitables to be able to handle our tasks simultaneously. Any question? Okay. So how is this important? When you work with Docker, you work with cloud-based systems or web-based system, as we mentioned in the lecture. A lot of the times it's needed because Python is often used in web environment or even on cloud environment. So when you work with system that requires real-time or high responsive from the client or from the server end, you need to make sure that you think about how you can implement asynchronous programming. Okay. So when we finish the program, what we can do is we can take a screen capture showing that we did the program. And for question 4, it asks you to explain the role of the coroutines in this program. So when you take a look at the function that relates to the coroutines and the comment, you can see that's there. So the coroutines allows you to put in the awaitables. You see the key term await here. And that when it pauses, it's actually going to be able to handle the other tasks during that time. Okay. And the same thing down here as we would be comparing the loops. So when we add in the coroutine for the loop, instead of executing from 1 or 0 through 9 or 1 through 10 for the task, what it's going to do is going to pick up the task simultaneously instead of going sequentially from the beginning to the end. Now, as you look at the parameter here, right, we are going to use as you look at the asterisk, it's going to be pointing back to the list of the task, which is happening here. So in the second asynchronous function, you see that we actually create a list of tasks, and we implement that loop to be able to access each of the tasks. However, right, since it's already stored in a list, you don't have to pull it from the list. You simply point to the location of the task to be able to see what that is. Okay, so for the coroutine, in the second asynchronous function, we simply create a container that holds our task and then implement the awaitables and point to the task. Okay. And so you would still have access to the task, but it won't execute it as in a synchronous way. It will be asynchronous. And in a synchronous way, it will just sequential from 1 through 10, where asynchronous, it's going to be out of order, but it's able to handle multiple tasks together. Okay. So in 5, it asks you, how is the execution for the asynchronous task differ from the synchronous task in the program? And I just mentioned that, right? So when you look at the output, you can see for the synchronous, we have 1 through 9. Okay. And then for the asynchronous, as it implements the coroutines for the await, it will be executing it out of order. So when it's finishing 1, it's already doing that wait time, it's queuing 5. And as it finished 5, it's already queuing the other. So that means that it doesn't necessarily have to go from the first to the last in a sequential way. Because if you have a hang up doing the first or somewhere in your task list, right, it might not get to the end. So that's the disadvantage for the synchronous side, is that if there's something blocking, you can't prevent that from happening. So in this exercise, we learn how to implement a coroutine. Simply, we define that as an asynchronous function. We implemented the wait or the awaitables. Okay. And then the second way that we did with the coroutines is we implement a task list, and we use the gather method to be able to point to the location of the task, so that way it can execute. Any question? Okay. So when I wrote this lab previously, I really wanted to see if we can apply this to something that's real world, right? And the whole point in this is to show you that how this can be used for web services. Okay, so in this exercise, you are going to use 2 libraries. One, we already used that in exercise A. And the second, you are going to use AIOHTTP. This is one of the libraries that's normally incorporated for web-based programming in Python. There are HTTP libraries that are also popular, but you're going to see the AIOHTTP libraries is often used. So when the client system communicate with the web server, or when you use your browser to visit a website, right, in the book or in the chapter, we talked about how there are 2 requests and 2 reply for HTTP as it uses TCP. So the first thing is it needs to make sure that the connection is established. So the client would send the request to the server and say, hey, can I connect to you? The server would respond and say yes. And then the client would say, can you serve me this site? And then the web server would say, oh, yes, here it is, right? So you need to have the get HTTP request to the server from the client side. So what we can do with this is we can handle the calls in an asynchronous way, as is shown in your textbook or your notes, where we can handle the requests concurrently, instead of waiting request, reply, and then request, and then reply, that will be synchronous. So if we're able to handle all the requests for the service at the same time, it's gonna save us some time, especially in the response to your client system requesting for, could be web pages or web services. So each request yields the control flow for the next and returns when it's complete. So to retrieve the result from all the requests, that takes only as long as the slowest request. So if you have a request that's really slow, it's going to hang up all the future requests. So what we can do is, because if we do it in an asynchronous way, we can handle all the requests at once. So that way our total time for the elapse or the delay is going to be less. It's going to be minimal. Now, here it says that the main difference are due to your library implementation. And this is really important, especially for Python, is the library that you use is gonna be a way that how you can improve your program as well. So in this case, what we can do is we can create the task and waiting for them to finish. But instead of having them blocking, we can actually handle multiple tasks at the same time. Okay. So just like the last one, we are going to tap into the coroutines and we are going to create a group of tasks and we're going to make some of them wait while the other one finish. So if you're using command line, you need to pip install Asyncio and AIOHTTP. If you're using an IDE like me, you simply just add. You already did the Asyncio for part A. So you just put AIOHTTP. And you should be able to find. And if you look at the brief description that it tells you here, right? This is for the Async HTTP client and server framework, and it works with Asyncio. Okay, and this is for the version 3, so it will work with Python 3. Okay, so let me open up my part B. Let's clear this. Okay, so here we're going to use time. We're also going to use URL lib request. This is to convert your URL to an actual public IP address, because all the websites out there uses public IP. And then for the async IO, we already talked about that for asynchronous programming. And then this is to handle the get HTTP for asynchronous. So we have a variable called URL, and this is what you normally do when you write a Python program for your web, is you have a container that stores your URL. And you want to put your URL in quotation marks. Okay. So let's say if you write the web application for your company to test your web server, right? You just put in your web server fully qualified domain name there with its extension. So if you want to test a certain page or a certain service with that URL, you would put in the extension page. Okay. And here we can specify the max number of clients. So here we can just put 3. Okay, and you can test it with different value. And so we define a synchronous function, and this is going to be fetch sync. And just like before, we want to see the process ID, which is just the process number. And we want to print that out. And we're going to start the clock. So that's why you're using the time library there. Now, when you visit a site, right, if it resolved, right, it uses a certain code. So if you ever visit a site and you get an error, like a 404 error, right, that needs to really be handled with the request and the response. So here we have a response container that's gonna be storing, right, how that request is being replied to by this URL. So when this URL is submitted, right, it needs to send that as a request. So it opens that URL. And then all your traffic to the web has some form of message header. That means that when you submit the request, that comes, and if you're familiar with networking or communication, right, it has a header. Think of it like a postal mail, right? Like you would have where it's going to, who is it sending from, what is the weight for the mail or the size of the mail. Well, your web message is exactly like that. It has a thing called header. And in the header, it has like the packet information or the request information, the source, the destination, right? Some of the body information, how the order. So it also have a timestamp when it was sent. So what we're going to do is we're going to pull the date from that. Okay. And then we are going to print out the time with the date time. So that's going to show the date that it's submitted. So we're going to print the process ID, the date, right? The actual time minus the start. And we're going to return the date time. On the asynchronous side, right, what we're going to do is we are going to use async IO. We're going to define a function called AIOHTTP get, and we're going to pass the URL. This is going to do the same thing, but because we're using the library, it's slightly different than what we would see in the synchronous side. So for the async, we're going to use async with, and we are going to use the method where we would establish the client session where it's still going to request using that URL, but because this is written as a client session in the HTTP library, you have to use the method that's defined from that library. So this function simply is going to submit the request to the server using the URL for the session. And then we are going to have the statement where it would get the URL as the response. So this is the client side. This is the server side. So we're going to get the server response and we're going to return the response. Okay. So in web programming, you're always going to have the request and the reply side. Right? The request is from the client and the response is from the server. Same thing here. The request is from the client. You submit the URL and the server is going to respond. Then the third function is also an asynchronous function. This is going to be your fetch async. This is going to allow us to print out the information like what you've seen in the last one. So we are going to print out the process ID, the process number. We're going to start the clock. And then for the response, we are going to implement awaitables. So when it goes out and it gets the URL, it's going to have the awaitables. So this is where your coroutines come in. Then your date time we are going to pull the information from the header and we're going to print the date just like the other one. After that, similar to your synchronous function, you print out your process ID, the date, and the total time that it takes. So we take the time, subtract the start, which is what we start with the clock up here. Now, all your requests needs to close, okay? You don't want to leave it hanging, so it's a good practice that you close the session. So after it's done responding, we wanted to end that. And then we're going to return the date. Then on the synchronous side, you are defining another function called synchronous. You have the clock that starts. Just like part A, you're going to see something similar here. We're going to do a loop, which is a range. And because we have more than one clients, right, we can loop through our client requests, because recall that earlier we said that we might have more than one clients. We have 3. So that means that we have to loop through. And we want to call on the fetch sync, which is the first function that we define to access for each of the client. So this one is going to go with this one, okay? So that way we can respond to the client accordingly. And then we're going to print out the time that it took to reply to the client. And then lastly, we are going to have asynchronous function. This one, you are going to start the clock. And similar to part A, you are going to have a list that's going to have a task group, a group of tasks there. So here you define a list and you would use create task method. In that, you're gonna call the fetch async to access. So this is going to be a loop similar to the synchronous one. But we want to write it as a coroutine for the concurrent programming for asynchronous. You would need to call the asynchronous method that or function that you previously defined. Then we are still going to loop through for multiple clients. And as we are handling their requests, right, you want to implement awaitables. So that way multiple get can be handled at once and multiple response can be handled at once. And we want to measure the time that it takes to compare. So then we would print out synchronous, call the synchronous function. We print out asynchronous. And in the asynchronous, recall that when we discussed this in the lecture, when you run the asynchronous function, you use the run method and you pass it inside the run method. Okay, so you would use async.io run and then you call the function inside the parameter there. You pass the function. Okay, so with this, we are going to run. Okay, so it tells me that this is the process 1 for the synchronous, right? It took 0.45 seconds. Process 2 started, so I started process 1 and process 2. For the request, process 2 took 0.515 seconds, so 0.15 seconds. Then it started process 3, and that took 0.39 seconds. So altogether, right? So the process overall took one second. For the asynchronous side, and that's predictable for the synchronous because it goes from 1 to 2 to 3. For the asynchronous side, it's going to fetch 1, then so 1 started, 2 started, and 3 started. Then it's going to handle, because while it's waiting for 1, it's going to execute process 2, and that's 0.36 seconds. After that, it's going to execute process 1, 37 seconds, and process 3, 36 seconds. So you do see about close to 60% improvement or 50% improvement, roughly. Okay. So in this exercise, you can look at how synchronous would be for web, for HTTP GET, and asynchronous for HTTP GET and response. Also, we have to consider other factor too, right? Connection. So one of the area that we would be account for is, you know, when you measure this, if your connection on your client end is slow, right? It could also be slow. So, or the server side if it's slow. So depending on how you're hosting your web server, okay? So that will be another factor that we should consider when we're looking at the response time. But simply, you know, from my end, when I run this and, you know, I'm connecting, let's say that I'm on the school network and they're running fiber backbone, and I'm on the wireless side, so it's diluted a little bit in the connectivity. So there is some consideration for connection when you look at the time measurement. Now, if your server connection and your client connection are both really slow, it's still going to be able to handle asynchronously and synchronously. It'll just be slower in the response of the time. So your time is going to be in the higher values. Any question? And you can check this out, right? Like if you have a website and you wanted to test it, you can take a look at that on how you would be able to put in the URL to test. Okay. So that was part B. And I copy and paste this instead of screenshot because it is a little longer in the program. And there's like a lot of formatting. You can include the comment so that way you know what that section is about. So after you run the program, provide a screen capture of your code and your output. For 10, it asks you to describe how asynchronous processes differ from synchronous process, right? We talked about how we implemented the coroutines. So when you look at the function definition for the asynchronous side, right, there are 2 parts or multiple parts to it, okay? This is for the communication with the get and response, okay? And then for the second part, this is just to also print out the header information. And this is where we would create a task list and loop through it. But as you loop through it, you want to implement some wait. So you want to have the awaitables. So that way it just doesn't loop from the beginning to end. It's actually able to put things on pause while it's executing the others. And so even on the synchronous side, even if you program it synchronously, you still have to have multiple parts, as you can see from the beginning to the end there. Okay. So you have to handle the request and response, like submit the URL to the server and so on. And then for the second part, you need to loop through and respond for the client. So you have to call the other function. Now for 11, compare the time to execute asynchronous and synchronous processes. Do you see a huge improvement? Explain how synchronous slowest process is faster than the synchronous slowest process. So if I take a look at my output, let me see if I can pull this up back again. So the synchronous process that's slowest for me is process 1. That's 0.45 seconds, and it might be a little different for you. As I said before, our connectivity should be considered, right? Then my slowest process also for the asynchronous side for me would also be process 1, right? I do see the difference in about 0.08 of a second between the synchronous to the asynchronous. So I had improved about 0.08 of a second. You can do the calculation for speed up as well, but when we look at that, right, we would see that implementing the coroutines actually help in how the servers are able to handle multiple requests. Because when you see here, it started 1, 2, and 3. But then it addressed the process 2 before it addressed the process 1. Because if we do it asynchronously, it has to wait until process 1 complete in order to move to process 2. So by doing it asynchronously, we are able to make it out of order where we don't have to wait for process 1 to be complete. It's able to resolve the request for process 2 first. Okay. So implementing the coroutine with awaitables definitely handle the task better. Okay, any question? Okay, pretty easy program, just HTTP request and reply. So moving from part B into C, you're going to see something similar. So not a huge modification, but in this one, we're going to add in features. Okay, remember we talked about features to track. So in part C, it tells you here that coroutines can be scheduled to run to retrieve the results in different ways. And if you need to process the results of HTTP requests as soon as they arrive, for the part C program, you're going to implement padding, and we can schedule the call at the same time. The results, like what you see similarly to the last one, is going to arrive out of order. So your process is going to be handled as soon as it can, or it's going to show as soon as it can be handled. Now, in the previous exercise, we saw that we implemented multiple functions for asynchronous and also synchronous. We also implemented the coroutines with awaitables. In this one, what we're going to do is we're going to do something similar, but we are going to put the coroutine in the list and we're going to schedule and execute. So we're going to use an askComplete function. And this is going to yield an iterator and it's going to have a yield, right? We talk about a yield for futures. So this function is derived from concurrent futures module. So when you use this, it's like the same thing as using concurrent futures. Okay. So in part C, we're going to use futures. All right, so let me get part C open. Let's clear this. Okay, so the same library as you used in the last one. And you're going to see that we have the variable that holds your URL. URL is in quotation mark, your client values. Then we have the asynchronous function. And just like before, right, we established the web session. So that's going to submit the URL. So it's going to do the get URL. And it's going to return the response. So that's sent to the server from the client. Then the second function, we're going to print out our process ID. So we start the clock. And in this one, we're going to do the sleepy time. And we're going to randomly generated integers. Then we're going to print out our process ID and the time. So this is still a pause, right? Then your awaitable, in order for it to wait, then we want to use await as a keyword, and then we have it sleep. And the value is going to be pulled from sleepy time. So for the response, we're going to have it with the awaitables. Okay. And we're going to call on the get URL or AIOHTTP, which is from here. So call that method or function. And we're going to pull the date from the header from HTTP. Close the session. Then we're going to return process ID, date, and the time that it took to handle that process. Then we have an asynchronous function called main. So then we start your clock, and here is where the futures come in. So your futures, similar to the last one, but in this one, you're going to create a list. And in that, we're going to use fetch async, which we previously defined. So that function is going to access the index for our loop, and we're going to loop through the number of clients. Then we have another for loop. And for this for loop, we're going to enumerate. So it's a loop inside a loop, right? And it's going to use as completed, right? Remember how we said that it is as completed? And we're going to pass futures, which is from here. Okay. Then as it loops, what we're going to do is we're going to have the result. And here is where we're going to have the awaitables. And we're going to put in the future. So the pause time is really coming from here as it execute fetch async. And then we're going to print. And then ultimately, we want to print the overall process time. So at the end, to really run your asynchronous, right? Because the main we call fetch sync, and we also called, what was it? Yeah, so fetch async is called there, and then we have this one called the others, okay? The first. So the second called the first, and the third called the second. So with that, we would then run the main. Okay, so remember that when you use async IO, at the end to really call your function, you would use the run method. So all of these work together. The first one to submit your request from the client. The second to generate your wait time for features or for your awaitables, which is then tracked with features. Then the third is to implement features by calling the second for the fetch. Okay, so to get features to both work, we have to have those two functions work together. And in the fetch async, notice that here is where you are setting up the awaitable also for the response. So the server reply. Okay. So now we're going to run. Okay. So it tells me that for the process 2, it started. It sleeps for 4 seconds. Remember that this is randomly generated. Okay. So it gives me 4 seconds. And then it's going to start process. So while it's waiting for a second, it started process 1. And then process 1 goes on pause for 3 seconds. Then it start process 3. Then it goes on pause for 3 seconds. Okay. So my process 3 took 3.49 seconds. Process 1 took 3.55 seconds, and process 2 took 4.13 seconds. So the longest is my 4.13, right? And yours might look a little different as we randomly generated this. Okay. So after you complete the program, we would then need to take a screen capture to show your code and your output. So in part C, the program overall, we don't have any synchronous pieces, right? We simply write a purely asynchronous program. All the 3 parts work together, all the 3 functions to handle the request from the client, to generate. So in the second function, you would see that we implemented the awaitables for the coroutines, and then use that with features in the main. And so for number 15, you want to focus on how the main function is defined. So as it looks through, right, instead of going from process 1, process 2, and process 3, as you can see in the result, my process 2 gets started first. So it doesn't necessarily have to be sequentially accessing the process. And as it sleeps for 4 seconds, it works on process 1. And as process 1 sleep for 3 seconds, it starts process 3. So if process 1 is the longest, we don't have to wait for that to be done. It finish process 2 first, and then come back and finish process 1. And that's what it's showing you. Okay. Any question? Okay, so now we went from both synchronous and asynchronous program, right, for HTTP requests to a fully asynchronous program for HTTP requests. The main difference in this one compared to B, you would see that we did generate the random values for the wait time. Okay, right here for the sleepy time. And then we will implement that for coroutines with the awaitables here. And then another difference is that we implemented features. So it can queue, right, the upcoming process and started that while it's finishing the current. Any question? So with this, you're able to see how you can write an asynchronous program for HTTP for web server requests. Okay, no question. All right, so one of the areas that I want to hit is going to be for your reactive programming. And so that's why I wanted to implement this part to show you how you can do this. So RxPY or reactive programming is a library that we can use for asynchronous. And this is event driven. So it's going to use observable collections and pipable query operators in Python. So I'm going to define that below. So anytime that you require data calls, especially when you're thinking about database queries, right, asynchronous is ideal. And you might have callbacks and event. So event-based programs, you know, you can see this across not just for web access, web server response, and so on, but we would use it a lot, especially when you're handling data streams. Okay, so Rx or RxPY is really good for asynchronous data stream, where the data stream is using a certain operator like filter, sum, concat, map, etc. And there's a link for your documentation. And it talks a little bit about how you can create observable object. And with that, you have access to some of the methods for observable. So here it gives you a diagram on how that would be. So observables are functions that create an observer and it attaches to the source of having data stream as expected, like tweets. Okay, so social media websites or web apps often use this because it's event related, right? So if somebody posts a tweet, that's an event. So observables are functions that create observer. So what is an observer? An observer is just an object that uses on next, on error, or on complete methods. So those are the three actions that can happen. And so these actions, right, can then get called with the observer or with the observable. So you can look at the incoming tweets, right? That will be on next. Or in the case that if you don't have a tweet that didn't submit properly, that will be on error or uncompleted when it is successfully submitted. So observables create observer, which is an object. The subscriber executes the observables. Okay, subscriber executes the observable. Then your operator is another function that takes the input and the output of the observable. It is also known as an observable. Slightly confusing. So you can use multiple operators on an observable data by using pipe operator. So the operator is a function that takes observable input and output. Let's just know that. Then the subject is an observable sequence. It's also known as an observer that can multicast. So that means that it can talk to other observers that subscribed. So an object, right, if it's subscribed, that means that it is used in a function, okay, that executes the observer. Then another element is the scheduler. So this allows the task to be executed in parallel, simultaneously. And this is why you see this is for web app. So this part here, it says to make that happen, your RxPY has two operators subscribe on and observer on. This works with the scheduler to decide the execution for the subscribe task. Okay. So before we do the program, check out this section so that way you can see like the objective of the program. So in the below program, we're going to make a stock trading system. It will buy and sell the stock based on their price, right? It's event driven. We then want to create an observable object that will emit events based on the value of the stocks. So that means that we would buy the stock when certain things happen because based on the price, right? So we would define the function by stock event, and the parameter will be your observer, which is the object, and the scheduler. So it's going to iterate over your stock array, and it's going to use the onNext function whenever the stock price is greater than 100. Okay, so we would check based on that. And so if you ever do like trading, you can set the criteria, right? Like you can buy when the stock goes below a certain amount and sell when it goes over a certain amount. So that is an event-driven type of action. And so on the mobile app or on the web app that you see, right, the developer, what they do is they can implement something like this where it can be handled quickly. So once we set the criteria, then we can subscribe the observable object. We're going to use Lambda functions to call the subscribe. And Lambda is a no-name function. Think of it like a function placeholder. Okay, because what we want is we can fill this in depending on the event that occurs, right? We don't know whether the stock is going to be, right, high or low. So that means that we would be able to pass on next. So on next is called whenever the observable emits something. So it's going to go to the next task or the next item on the stock list. OnComplete is called when it has nothing else to give. And OnError is when you receive an error in the observable. So you can't fully predict what will happen, but in this range of action, you can have it toggle between the three or across the three: OnComplete, OnError, or OnNext. Which is why we have to use a Lambda function. Okay, so we need to install Rx. Okay, do not use RxPy because that's a different thing. That's regular expression. We don't want regular expression. Okay, so on your IDE, make sure that you add in the package. So you can say Rx. You want reactive extensions. Okay, because if you search for RxPy, you're gonna get regular expressions. Then we're gonna install that. Okay, and I think I have part D here. Let me clear. Okay, so this is arbitrary. It's not realistic because stock price for this is different now, right? Even with the recent split. So what you have is you only gonna need Rx for this one. So you just need to add the library. Then you're gonna write the import statement. We are going to import in observable from Rx, and we're gonna use create from Rx. We have a list, right, that contains our stock. And this is, if you're familiar, right, you learned that this is a list that contains a dictionary. So we have our stock ticker and then the price. Then we have a function. And simply this is to buy. So we're going to pass observer and the scheduler, just like the description of the exercise. So the parameter here is the observer and the scheduler. We have to loop through our stock. So we have a for loop, but we want to implement the condition. The criteria is that if your stock price is greater than 100, we're going to use OnNext. Okay. So we're going to call OnNext. If the stock price is less than or equal to 0, we're going to say OnError. So we're going to call OnError. And then lastly, we would have observer OnComplete. Now, next is going to be source. We are going to create the stock, the buy stock event. So Here is where you call your function that you previously defined inside the create method, which comes from Rx. Okay, so that's how you're going to be able to call that function. It's going to store it in source, which is an object. Now you're going to take that object and you're going to subscribe. Okay, so after you iterate through and put in the condition, you have to create an object so you can use that object for subscription. And as we mentioned before, we are going to put in our lambda. So on next, we put lambda. And for our value, we're just going to print. Then on complete. So if we can trade, right? Then we're going to print complete trades. Then on error, then we're just going to print out the error. Okay. All right, so now we're going to run. Okay, so here, right, we see that we receive instruction to buy. We receive instruction to buy. We receive instruction to buy. And then lastly, because this is 0 for that ticker, it's just going to print out that ticker. Okay, all of these are over $100. So we buy, right? This should be the other way around. So realistically, I would buy when it's less and sell when it's higher, right? But you get the idea. So you can put down like $10, anything above $10 you can buy, right? And then you can add in an additional function to sell. So def sell stock event, and then you can put in the criteria. So if it's over, let's say $300, you're gonna sell or trade. Okay. So in this exercise, you would see that it is reactive. Okay. And what we can do here is instead of statically put in the value, right, you can implement a list that contain information, and you can also link the data from the market values or, stock market values, and you can plug that in. So it can feed it from another server and then put that in here. And this can change throughout. So we can update it and then be able to trade or buy or sell or print out error. So the important takeaway from this is when you're using Rx, okay, you need to make sure that you have your observer and your scheduler. You need to have an object, and you need to use that object for subscription. And there are only 3 methods that you can implement with Rx for the subscription: on next, on complete, and on air. Okay. Question? Okay, so as we complete part D, provide screen capture for your code and your output. You can explain how reactive programming is integrated in the program. I went through that. I'm getting an error when I import observable and create. Did you install the library? So in a little bit, I'll let you share screen and see what kind of error you get. Okay. Okay. So explain how your reactive programming is integrated in this program. And then explain the functionality of observable, observer, and operators in this program. So I recommend coming back here and look at the definition for those and see how those components work in this particular program. What an observer is, what an observable is, what a scheduler is. And you can modify these values as they are. You hard code them in here so you can change them and see how that works. If you put 1 to 0, is it going to be able to respond? It should be. Okay. So the element for this is when you define the function, right? Here's your observer. On next, on error, on complete. So those are the methods that would be the operators for your observer, and then your object and the subscription for your object. Okay, any questions? Not too long, just a few exercises to show you how you can apply this. Okay, this is due on Sunday. You don't have to submit it today. I think I'm caught up as far as all the stuff that we submitted last week as of yesterday. So if you have anything outstanding, you can still submit that. Okay. All right, I'm going to go ahead and stop share and stop recording. Let me see. Okay, got everybody.